During this video, we are going to review the concept of electron configuration, valence shell, and valence electrons. It's important that we understand the concept of valence shell and valence electrons. Valence shell is the outermost orbital shell of an atom, and we are going to get it from the electron configuration. And the valence electrons are going to be the electrons that we have in the valence shell. Okay, so just reviewing here or writing here. Valence shell is the highest energy level in electron configuration, and valence electrons are the electrons in valence shell. The first thing that we have to do in order to determine the valence shell and the valence electrons is we have to make the electron configuration. Okay, so we are going to review how to make the electron configuration, and after that we are going to calculate the valence shell and the valence electrons. Okay, we have the following elements: selenium, that has an atomic number of 34. So in order to determine valence shell and valence electrons, first of all, we have to make the electron configuration. Okay, remember that in order to make the electron configuration, we need the atomic number, and then what we have to do is we have to fill all the energy levels following the off-boat diagram and completing according to the electrons that we have in each one of the sublevels of energy. Remembering that for sublevel S, we have a maximum amount of 2 electrons, for sublevel P6, for sublevel D10, and for sublevel F14. Okay, so let's start writing the electron configuration for selenium. We start with the first energy level, which is 1, and it would be sublevel S with 2 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and let's see how many electrons we have. We have 6, 8, 10, 16, 18, 20. We are 20 so far. So after 4s, we have 3d. Okay, so we have 10. And this will give us 6, 8, 10, 16, 18, 20, 30. And after 3D, we have 4p. And since we only need 4 more electrons, I will just add the number 4. Okay, why we can leave the last level incomplete? Because that's the only one that we can leave it without completing, because that's the last level of energy and the sublevel that we have. If we sum all the exponents, the sum of all the exponents must be equal to the 34 that we have of the atomic number. Okay, so we have 2 plus 2, 4, plus 6, 10, 12, 18, 20, 30, and 34. Okay, so this is the electron configuration of selenium. If they ask me to write the valence shell, okay, what I have to do is I have to find in my electron configuration the highest energy level. Okay, remembering that the energy level is the big number that we have in the electron configuration. So which is the biggest number that we have in the electron configuration? Okay, we have 1s, 2s, 3s, and here we have 4, and here we have another 4. So I will take all the biggest numbers in the electron configuration, okay? So in this case will be 4s2, 4p4. And this will be my valence shell. That's the highest energy level of the electron configuration. I will not take the 3D, okay, that I have in between the 4s2 and the 4p, because that's not the highest energy level. Okay, I will just take the 4s, okay? And the valence electrons, okay, valence electrons are going to be the electrons that I have in my valence shell. remembering that the electrons are the exponents that I have in the valence shell. So in this case would be 2 plus 4. The valence electrons will be 6. Okay? Now with this information, we can determine the position of the element in the periodic table, okay? So this is what we're gonna be doing, okay? This is, it's important to consider that this is only for representative elements, okay? If we have transition elements, we will calculate differently the valence shell and valence electrons. If we have representative elements, the ones that we have in the ACE groups, this is what we are going to be doing. Okay, so remembering the valence shell, we have 4s2, 4p4, valence electron 6. Let's go to the periodic table. Okay, here we have a periodic table. If we remember what we just got in the previous slide, we have that for, let me just write it with that. For selenium, I wanted it with that. For selenium, the valence shell was 4s2, 4p4. That was the valence shell. Okay? Now the valence shell can give me information about where selenium is located, okay? And it's individual or in this particular for each one of the elements, okay? The big number, okay, tells me the row in which we are going to find this element. So we have row 1, row 2, row 3, row 4. Okay, and the valence electrons, which is the sum of the two exponents, which is 6, will tell me the group in which we are going to find selenium, okay, or this element. So we have group 1, group 2, we skip the transition, 3, 4, 5, and 6, okay? So here we have selenium. Okay, so selenium is located, okay, in row number 4, okay, group number 6. Okay, so if they give you only the valence shell, you can determine which is the element that has that valence shell, okay, just by looking to the valence shell and the valence electrons. This works for all the elements in the periodic table for representatives, okay? In the next video, I'm gonna show you how to determine the valence shell and the valence electrons for transition elements, the ones that we have in the transition area or in the B groups, okay? So just reviewing what we just did, once that we have the valence shell and the valence electrons, the valence shell tells me where the element is located, in which row do we have it, or in which family do we have it. And the valence electrons will tell me, sorry, in which period we have it. Okay, the row is the period. And the valence electrons will tell me in which group do we have the element, okay? So the big number, once again, tells me the row or the period, okay? And the valence electrons tells me the group in which we have it for representative.